Can you see the screen?
Yes, sir.
Okay. Okay. So, good afternoon, everyone. My name is Arka Roy. I'm working as a Prime Minister Research Fellow in the Department of Electrical Engineering, IIT Patna. And I welcome you all to this last week 3 extra live session. So, in this particular session, what I have planned is basically I will be actually uh, solve some questions which are which will be related with the related with the quiz question as well as the question that you might see in the examination, final examination as well. So I have gathered several questions related with your autoencoders, CNN architectures, basic machine learning things, followed by the optimizers that we have studied, normalization process. But again, the thing is that just within 2 hours recapping the whole syllabus, it's might difficult. So I will be restricting myself with 30 around 20 to 25 questions. And if you want, I can give you some other sample questions. Basically, I have collected these questions. These are standard questions given some of the questions that we give here at IIT Patna to our students who basically take this deep learning course. I have taken some questions from other NPTEL courses, which comes under the same banner as deep learning. So let us now start solving those questions. And what I would recommend is basically because you will be writing the examination on 27th. So, and as because this particular lecture is basically on solving questions only. So, as because I have tried to cover the whole syllabus, tried to cover, but I know that it is very difficult to cover the whole syllabus within 2 hours. So, I would recommend you to sit with pen and paper and also try to solve the questions by yourself because it will be helpful because anyway you will be writing the examination on 27th. So, it's better to practice the things by yourself as well. Okay, so let's move to the question part. So this is the first question that I have taken. So the first question basically states that you have MP neuron, which basically aggregates the so you have a neuron over here, and this particular neuron, what it does is it aggregates the input. There's nothing new. We know that in case of basic neural network architecture, whatever node we have seen throughout the course, we have seen that you feed some inputs, that node, it will do a linear combination. So in this particular node, they have said that it basically aggregates the input. So that means there will be no linear combination, but it will be just a simple summation and takes a decision based on this aggregation. If the sum of all inputs if the sum of all inputs, so you can see over here I have given the diagram as well. So you have x1 to x4. So that means 1, 2, 3, 4. 4 inputs are there. So if you sum all inputs, if the sum of all input is greater than a threshold theta, then your output of empty neuron is 1. So you can think it as a neuron which basically first aggregates all these things, all the input values, and then if the summation is greater than some threshold theta, then it will give you 1, otherwise it will give you 0. Fine. We say that empty neuron implements a Boolean function if the output of empty neuron is consistent with the truth table of the Boolean function. Fine. So what they are telling is that this particular neuron basically tries to implement a Boolean function, and that Boolean function, it is basically written over here. So as because you are feeding 4 different neurons, so the Boolean function is dependent on these 4 input parameters, and this is the Boolean function that it basically implements. This particular neuron implements this sort of Boolean function. Fine. In other words, if for a given input configuration, so here it is important. So in other words, if for a given input configuration, the Boolean function outputs 1, then the output neuron should also be 1. And similarly, if for a given input configuration, the Boolean function outputs 0, then the output of the neuron should also be 0. So what does it mean is basically, so you have these sort of input parameters x1, x2, x3, x4, and you can see that there might be some combinations depending on which you will get either 1 as the output, as the Boolean output, and either 0 as the Boolean output. So they have written over here. So if the input configuration is such that your x1, x2, x3, x4, these basically satisfies this particular whole thing, then you might get 1. And if the input configuration that you have provided is such that if you do all these operations, then you might get 0. Okay. So the MP neuron for the above Boolean function is as follows. So this is the MP neuron. So what you have to find is what should be the value of threshold such that MP neuron implements the above Boolean function. And note that, so there is a note that circle at the end of input to the Maxwell neuron. So Maxwell not, so this is an MP neuron. So to the MP neuron indicates inhibitory input. So what is the meaning of inhibitory input? So they have also given that particular definition. If any inhibitory input is 1, the output will be equals to 0. So if I go to the picture again, so you can see over here, just change the color. So at the end, you can see arrow for these 2 inputs. And over here, you can see circles are basically drawn over here. So whenever there is a circle associated with any sort of input, so that those inputs are called inhibitory input. And what was the logic that was given? If any of the inhibitory input is equals to 1, then your output will be equals to 0. So that is also true. If I just show you why that is true, you can see that the Boolean function that you've been given, that is x1, x2, x3, x4, if I just write it simply, it would be x1, x2, then there is an AND operation, and x3 is complemented over here. X3, you can see that x3 is complemented here. So you can just write x3 bar, and then again x4 is also complemented over here. So it would be x4 bar. Fine. Now you evaluate the function. Let's say for these inhibitory inputs, when x3 is equals to 0, what will be the output? What will be the whole output when x3 is equals to 0? If x3 is equals to 1. Yes, anyone?
So 0.
Sorry?
0?
Yeah, it would be 0. Same with x4 as well. When x4 is equals to 1, then the final output is equals to 0. So that is basically they have meant over here. If you have any circle associated with any of these inputs, so those inputs are called inhibitory inputs. And if inhibitory inputs equals to 1, so the output will be 0. So that we also have proved. Now the question is, what would be the value of theta? So what would be the value of theta such that you can implement this particular function? So first I would request you to calculate this thing by yourself, and then so let's try it for 2 minutes by yourself, and then I will solve it by myself. So is the question clear or not?
Yes.
Okay. This question we have taken from the end semester exam 2021 CS 541. This was a 3 marks question. So how you are approaching this particular question? What is your approach? Anyone have tried to solve this question? Okay, so let me start solving the question. The first thing that you have to actually there are many things are going on over here. So one by one, whatever information is given over here, whatever logic is basically given over here. So let me first write it in terms of mathematics. So what they are saying is basically that neuron aggregates the inputs and takes a decision based on the aggregation. If the sum of all inputs is greater than the threshold theta, then the output of empty neuron is equals to 1. So on one hand, they are saying that they are trying to implement a Boolean function, and simultaneously, so this is one operation basically done by this particular neuron. At the other hand, the general working principle they have discussed over here. So what they are doing is basically they are feeding the inputs. If you sum all the inputs, and then if the summation value is greater than theta, then output will be equals to either 0 or equal to 1. So let us just formally write that thing over here. So I just copy this particular page only. So the first definition that they have given, y will be equal to 1 or 0. When it will be 1, the condition is summation of xi for all I should be greater than equal to theta, and elsewhere it would be 0. And what this particular neuron is implementing over here, they have given the function. So if I just write the function again, x1, x2, x3, x4 over here, so it is x1 dot x2 dot x3 complement dot x4 complement. Now we already saw that if x3 and x4, if any of them is 1, so the final output would be 0. And that is why they are called as inhibitory inputs. And you can see the corresponding circles are also associated with these two inputs. Fine. Now, as you can see, for this particular, you have 4 different inputs, and you are implementing a Boolean function. So how many combinations of input you can feed into this particular neuron? How many combination of inputs you can feed over here?
16.
Pardon, sorry.
16.
Yeah, you'll be able to feed 16 different combinations. So if I just start writing that particular combination, just this thing over here. So your combination of inputs. So x1, x2, x3, and x4. Okay. So 0, 0, 0, 0, 0, 0, 0, 1, 0, 0, 1, 0, 0, 0, 1, 1. This is the first set. Then 0, 1, 0, 0, 0, 1, 0, 1, 0, 1, 1, 0, 0, 1, 1, 1. Okay. Then I might run out of space over here. Okay. So we need to eliminate some of the cases. And what are the cases that we have to eliminate is, you can see that when x3 or x4, if that means either any of them is 0, so if either any of them is 0, then final output will be equals to 0. Simultaneously, if I just write this condition over here, if any of x1 or x2 is equal to 0, then also your final output will also be equal to 0, is it not? So this is the first case, that if either x3 or over here it could be 1. So the first case is, if either any of x3 and x4 is equal to 1, then final output will be 0. And over here, in this for this particular parenthesis, you can see that if either any of x1 or x2 is equals to 0, then your final output will also be equal to 0. So we need to first eliminate those cases. For example, over here you can see that x1, x2 both are equals to 0. So you can eliminate this case, because this particular case will give you the final output equal to 0. Then you also have to check that if either x3 or x4, if any one of them are equal to 1 as well, so that case will also give you 0 only. So over here, this case will also give you 0. This case will also give you 0, as x3 is equals to 1. Over here, x4 is equals to 1. Anyway, you can see that x1, x2, they are also 0. So this particular case also will not give you any result. It will give you 0 only. So over here, all these 4 cases are now nullified. So likewise, so just tell me that how many cases will be there which will represent this condition. If you expand this whole thing, so if I just write down the next patch, 0, 0, 1, 1, 0, 1, 0, 1, 0, 1, 1, and I think you can write the next level as well. So I have written down till 12th combination. So last 4 combination, you just write it and just tell me that how many total of this particular condition will be there out of these 16 input combinations, where either x3 or x4 is equals to 1. Just write down this thing at your in your copy, and then just tell me that how many cases will be there which satisfies that either x3 or x4 is 1.
Is it 15?
Sorry,
15, 1, 5.
15 cases you are saying, 1 5. So in 15 cases, you are getting either x3 or x4 is equals to 1. So let's check as well.
Is it 12?
No, not 1.
12.
No, 12 is also incorrect. Okay, so let us check here. So you can see that this is a case where either of x3 and x4 is equals to 1. This is also another case, and this is also another case. So over here 1, 2, 3. Over here also you can see that x4 is equals to x4 is equals to 1. So this case also you can nullify. Maybe 12 can be the correct answer. I also have not checked. So let me just write down by myself also. So over here x3 is 1, here x4 is equals to 1. So this particular case, you can see it is not satisfying. So this is the 7th one, this is the 8th one, this is the 9th one. And if I just write the last 4 cases as well, so 1 1 0 0, 1 1 0 1, 1 0 1 sorry 1 1 1 0, and last one is 1 1 1 1. Okay. So over here, this is not satisfying. So this is also satisfying. So this 10 and this is 11. Okay. So these cases, you can see that these inhibitory inputs are activated over here with 1, and that is why your final output will be 0 as well. So now tell me that from this particular function definition, or the Boolean function definition, can you tell me any combination of x1, x2, x3, x4 that for which your output will be equal to 1?
1 1 0 0.
1 1 0 0. So if your input combination is equals to 1 1 0 0, then your output will be equal to 1. So that means this is the case when you will get your final output is equals to 1, and then only for this Boolean function will be activated. And in any other cases you take, you will see that either due to x3 or x4 or due to x1 and x2, that the conditions we have already said that if any of them are 0 and if any of them are 1, then your final Boolean output will be equal to 0. So only you can see that this particular case is basically satisfying, that when your Boolean function will give you the value 1. So that means for this particular combination, x1 is equals to 1, x2 is equals to 2, x equal to 0, x4 equals to 0, your output is equals to 1. As because you can say that your f of x1, x2, x3, x4 is equals to 1, which also implies that your y, that is basically output of the neuron, that will also be equal to 1 only, because what you are doing is you are implementing a Boolean function through this particular neuron. So that basically means that the output of the neuron is represented by this f, as well as your output of this neuron also represented by y. So writing f of x1, x2, x4 is equals to 1 is same as writing y equals to 1. So this means that for this particular combination as f of this whole thing will be equal to 1, so we can write that y equals to 1, 2. Now the condition that we had written for the definition that we had written for y is y had a definition. It had the output 1 when summation of all input is greater than equal to theta, and in every other cases you will get 0. So now you can see for this combination only you are getting the y equals to 1, then obviously you are satisfying this relationship that summation of all xi greater than theta, as if it is satisfying, then only you will get 1. And as because you are getting 1 over here for this particular input combination, so you can say that obviously this particular function or this particular condition has been satisfied over there. So now let us try to find that what is the minimum bound of theta. So over here, summation of xi will give you 1 plus 1 plus 0 plus 0, which is equals to 2. And you can write 2 is greater than equal to theta. And in another fashion, you can write that this as well. So you can see that minimum value of theta for which your output will be equal to 1, that is theta equal to 2. So that means for this threshold is equal to 2, and only when your summation of all these input is greater than equal to 2, then only your output will be activated as 1. Otherwise, it will be equal to 0. So this is how you can get the value of theta. Any query?
Excuse me, sir.
Yeah.
Suppose if x1 is equal to 1, x2 0, x3 0, and x4 is also 0, then output should be 0.
Your again tell me the combination x1 is equals to 1.
1, x2 0,
Yes.
x3 0,
x3 0.
and x4 0.
Yes, for that also you will get final output is equals to 0. But we are basically
But
mainly
sum of xi is 1.
sum of xi is
1.
1. So you can see that your theta should be your maximum, your summation should be greater than equal to 2 only. Then only your output. There are two things. First thing is you can verify when you employ this particular combination into this function, into this f, your output is equals to how much? 0. But we are interested to know that only when your output will be equal to 1, that means this neuron is working. And only when you will get 1, then only you will know that obviously you have crossed that threshold. And for that particular output, you need to you have to calculate that what is the minimum bound of theta. For all the cases equal to 0, you will not be able to evaluate the value of theta. Why? Because you can see over here your final output is equals to 0. So if f of this whole thing is equals to 0, it is analogous to write y is equals to 0. And when y equals to 0, that means you have not crossed this threshold. Then you will not be able to, anyway, you will not be able to find the theta. And over here, our main aim is to find theta. And how will be able to find the theta value? Only when your output is equals to 1. So that means obviously you have crossed that particular theta value, and that is why you are getting the output. So over here, only this combination will give you output is equals to 1. So therefore y equals to 1. So therefore you can say that you have crossed that theta value. And from that definition, that all the sum of the all the values is equals to should be greater than equal to theta. So from there you have evaluated that your theta is equals to 2. Now if you work on this particular condition as well, that you got your theta should be, your threshold should be 2. If you cross that threshold or if you touch that threshold, only then you will get the output. Now with your combination from this Boolean function, so you are getting 0 only. Here also you apply the definition, you apply all the, you do all the summation xi, the summation value is equals to 1. And you can see that you are not crossing or touching this threshold value. And that is why also you are getting 0. So this is basically looking the problem from two different angles. If you go by this particular formula, you'll get 0 directly. And if you sum all these values, and as because you are not, this is not greater than 2, so therefore you can greater than equal to 2, so therefore you can say that again you will get the value 0 only, as because you are not crossing that threshold. So main aim is for this kind of question is to find that only where you get your final output is equals to 1, then only you are basically satisfying this condition, and then you can evaluate the value of theta.
Sir, one more question. Initially, we said there would be 16 combination. There should be 24, right?
No, you see that you are writing either 0 or 1. In every cases, these x1, x2, x3, x4, they can take either value 0 or 1. So how many digits it can take? So it can take two digits. And how many places you can place these things over here? So that you can do in this way. So 2, 2, 2, 2. So by this logic, you'll get 16 combination.
Thank you.
So you can do with this particular thing also. Let's say AB is your input, 0, 0, 0, 1, 1, 0, 1, 1. So you can take two values. A or B can take only two values, that is 0 or 1. And how many digits are there? There are two places. So over there you can write 2 square. So that is why it is 4. So this is the final answer. Okay, there is another similar question you can see. So over here the function is x1 plus x2 multiplied x3 complement and x4 complement. Now also you have to calculate that what will be the value of theta. So over here also x3 and x4 are inhibitory input. So that is why if any of them are equal to 1, then your final output will be equals to 0. Now please tell me that what could be the possible combination of x1, x2, x3, x4 for which you will get the function equals to 1. What will be the possible combination?
1 0 0 0.
1 0 0 0.
0.
Okay.
0.
Any other
0 1 0 0.
0 0. Any other
One-
combination?
1100.
1100. 1 second, I think someone is trying to join. Okay, so we know again the same thing, summation of xi all I should be greater than equal to theta. So now for case 1, you can see that for this your f is equals to 1. So writing f equals to 1 is same as writing y equals to 1. Similarly, writing f equals to 1 is similarly writing y equals to 1. Same thing holds over here as well. So to activate y equals to 1, we have to cross this particular threshold again with the same concept. So now let us see that what is that value of the threshold. So 1 plus 0 is equals to 1 only. And obviously, 1 should be greater than equal to theta. So that is why you have crossed that barrier. So let's say theta is something. Theta could be, let's say theta is 0.5, for instance. So as you are getting 1, the value 1, if I just remove this equal to sign, if I just stick with strictly greater than. So over here, as 1 is greater than theta, let's say theta is 0.5. As you can see that 1 is greater than theta, so you can say that you have crossed that particular barrier, and therefore you got your y activated as 1. And to know that what is the lower bound of theta, that what could be the lowest value of theta for which you can actually activate the output, that is y equals to 1. So to know that, what we do is basically we put a greater equal to sign over there, and we can write that the lowest value of theta could be 1. That means if you just touch 1, then only your output will be activated. So let us see the same thing for case 2. So over there also 0 plus 1 plus 0 plus 0. So again, the value is equals to 1, and 1 should be greater equal to theta. So you can say that theta's limiting bound will be equals to 1. Now let's see what is with case 3. So in case of case 3, you can see 1 plus 1 plus 0 plus 0 is equals to 2. And 2 is obviously greater than theta. So from here, you might see that the limiting value might be equals to 2. But in our previous cases, you already have seen that even that theta could be even smaller than 2. And even if theta is equals to 1 itself, you can activate the output over there. And that is why you can see that in these two cases, you are getting theta value 1, and over here you are getting theta value equals to 2. So even so we have to see that whether theta can take any smaller value or not. So out of all these cases, you take minimum theta 1, theta 2, theta 3, and you will get minimum of 1, 1, 2. So your final output will be equals to 1. So you can write your final theta is equals to 1 over there. Now let us check for all these cases that if I keep theta equals to 1, then whether I can basically get the final output or not. So if you add all these things, you are getting the summation value equals to 1, and it basically satisfied that the theta, it is your final summation is touching the threshold. So you can get the final output as 1. Same thing will obey over here. And similarly, you can see that 1 plus 1 equals to 2. this will give you the condition that is 2 is greater than 1. In other cases, it was giving you 1 equals to 1, 1 equals to 1. So this one is for theta. And here you can see in this third case, 2 is greater than 1. So as theta is equals to 1, you can see that already you have crossed that particular barrier to a sufficient unit. And therefore, again, your final output will be equal to 1. So for all these cases, you got 3 cases, and in 3 cases, you got 3 values. And we have to see that what is the minimum value that theta can take by which you can activate your output. And over here, by taking the minimum value of all these things, we got that theta value should be equal to 1. And from all these cases, we also have verified that in all cases, either you get equals to that theta, for which you will get final output equals to 1. Otherwise, in the third case, we see that the summation value is really it is greater than theta. And that is why, again, you can say that your output will be equals to 1. So by that logic, theta is equals to 1 over here. So any query for this one? Okay, so I hope there's no query. So the third question is, you have this neuron, which basically first do the aggregation or basically the linear combination. So over here, let's say the weight is W, and over here the weight is B. This is for the bias term. Then you first initially do that Wx plus B, then you are applying the sigmoid function. So this is a sigmoid function, and then you get the final output. And over here, the final output equation is also written. If it is just probably you cannot see the expression because it is written in very smaller font. So 1 plus e to the power Wx plus B. So you employ a loss function if this is your original output, and this is your neural network predicted output. And you are taking the loss function as squared error loss. So squared error loss. And what you've been asked is basically you have to calculate del L by del W and del L by del B. So please try to calculate first del L by del W. Yes, so what would be the final answer? Del L by del W? Anybody has tried to solve the question? Yeah, have you tried this one? Del L by del W?
Yeah.
So what is the answer for del L by del W?
Y minus fx into
1
fx
minus fx into fx
into 1 minus f of x.
into 1 minus f of x. So initially it was y minus fx you told, right? Y minus fx into 1 minus fx. Is it?
Yeah.
Okay. So any other answers?
Sir, it should also have into x.
Into x. Yes. And any other answers apart from this one? There is some minor mistakes there.
Sir, can you show the options D? Or there are three?
There are 3 options only.
So why is that negative? I think that's not clear.
Okay. So let me go to the next page and then let me start solving this one. So you have this neuron over here. X is coming from here, and this is bias 1 W. So what you will get over here, let's say this is written as Z. Z will be WX plus B, and then you apply a sigmoid over here so that you get the f of x as you can, let me write in terms of z first. So it would be f of z. So that means it would be sigma of z. So you can put wx plus b over there. So then the function would be in terms of x. So I just have written in terms of cascaded form so that I can write the chain rule efficiently. So z is equals to wx plus b. And your loss function is equals to half y minus f of x whole square. So you've been asked to write del L by del W. So now you can see your loss is basically dependent on this particular thing, right? So if I just rewrite it with some other variable, let me write this as t. Okay. So your loss is now first dependent on t. So you can write del L by del t. Now your t is sigma of z. And this sigma of z is basically the sigmoid function. So what we have to take is basically the derivative of the sigmoid function. So over there, you have to take del t by del z, as because the argument of sigmoid is z. Now you can see z is constructed with w. So you can write, you can basically take the derivative of z with respect to w. So in this way, you can see that del L by del W can be found. So this is the chain rule. Okay. So this term is for sigmoid's derivative. This term is for z's derivative. So if I just write over here, so the sigmoid's derivative, what it will give? So we have seen that f of x is basically sigma uh, of that whole thing, sigma of wx plus b, sigma of wx plus b, and we are basically taking the derivative of this sigma thing. So we get f of x multiplied with 1 minus f of x. That is the derivative of sigma. And this is the derivative of z with respect to w. So if I just take the derivative over here with respect to w, I will get x. Now the thing is that what will be the derivative of del L by derivative of the loss function with respect to this t variable. So if I take del L by del t, it would be half into 2 into y minus t. Then, as because we are taking the differentiation with respect to t, again we have to take derivative of this whole thing. So what I basically mean is that multiplied with dt y minus t. So y minus t, this two will cancel each other, and then you take the derivative over here. So y derivative of y with respect to t will be 0, and derivative of t with respect to t will be 1. So that is why you can see that it is y minus t, and you can write that it is minus y minus t, and we have written t is equals to this thing. So again we can write it as y minus f of x into f of x into 1 minus f of x multiplied with x. Is it now clear that why this minus has came?
Yes, sir, got it. Thank you.
Okay. So likewise, you have to do del L by del B, and that is also pretty straightforward. So over there, the chain rule will be just the same: del L by del T, then del T by del Z, and del Z by del D. So you will similarly you can evaluate that particular expression. So if I just go here, you can see that option C is satisfying this answer, and only in option C only you can see this minus sign. So option C is the correct answer. And similarly, you can do the computation over here as well. So just if I go to the next page, in this particular case, del Z by del B will be, this term will be vanished, and this term you will get 1 over there. So it will be minus y minus f of x multiplied with f of x, and then 1 minus f of x multiplied with 1. So therefore, again, you can see that this particular option is also satisfying. Okay. So now let's see the next question. The next question states that your final E is basically governed by this equation. And this particular f function, previously it was a sigmoid function. Now it is a tan hyperbolic function. Now what you have to evaluate is del E by del A. So first you can try by yourself, and then I will solve. Del E by del A you have to evaluate. So what will be the chain rule over here? Let's say this thing E is equals to f of z, and z you can write it as E into ax plus by plus dz. Now if you try to evaluate del E by del A, so what will be the chain rule? Okay, so it would be, first you can see that E is made up of Z. So you can take derivative of del E by del Z. And then what you are doing is basically you can see that you have to take final thing is that you have to take the derivative with respect to A. Now you can see Z is made up of E. So you can take the derivative of Z with respect to A. Is it clear? Okay, so this thing basically contributes the derivative of tanh function, and this is straightforward. This is basically the derivative of this thing. So what we have to do is we first have to evaluate that what is the to call the derivative of tanh function. So tanh of z, it can be written as e to the power z minus e to the power minus z divided by e to the power z plus e to the power minus z. So if you take derivative, what will be the output of the derivative? If you can tell me that what is the final output if you take the derivative of tanh function? If I just go to the next page, let's say del E by del Z, if I have to calculate, it is basically del Z of e to the power Z minus e to the power minus Z divided by e to the power Z plus e to the power minus Z. So if I just take the derivative, it would be e to the power Z plus e to the power minus Z whole square, and then you can write e to the power Z plus e to the power minus Z. Take the derivative of this thing, it would be e to the power Z and plus e to the power of minus Z. Then this thing will be constant now, e to the power minus Z, and you have to take derivative of the denominator. So you'll get e to the power Z minus e to the power minus Z. So you can see that you are getting e power Z plus e power minus Z whole square minus e power Z minus e power minus Z whole square divided by e power Z plus e power minus Z whole square. So you'll get 1 minus e power Z minus e power minus Z e power Z plus e power minus Z. So can you recall that what function is this one? What is this function?
Ten. 10h.
Hyperbolic
Yes,
time.
this is tanh. So 1 minus tanh of Z, its whole square. And over here, the tanh function is basically represented by f. So let me just write it as 1 minus f of z whole, not f of z square. Okay. Now we can just write del E by del A is equals to del E by del Z and del Z by del A. So if I take from this particular page, the expression of Z is written over here. So if I just take del Z by del A, the output will be C then multiplied with x, and rest of the things will be 0. So del z by del a is t into x. So it would be del e by del z is written over here, 1 minus f of z square, and then to multiply c into x. Now the definition of z was written in the previous page. It was c into ax plus by. So c into ax plus by plus okay, so over here z is the variable. So we have to choose some other variable name because already z is coming over here. So you can consider that this is some other variable. So this is d into z. So let's say this is z hat. Everywhere z is replaced by hat. Okay. So you can write f is of z hat, and over here also the things will be in terms of hat only. As because you can see there is a the same variable name is already existing. So z hat is written as c into ax plus dy into dz. So if I just plug this value over here, so it would be 1 minus f of c into ax plus dy plus dz, and obviously there is a square over here, and then multiplied with cx. So now let's check. The answer is 1 minus this whole thing, and there is a square multiplied with cx. So option A is the correct answer. Any query on this one?
Sir, can you explain the derivative of 10h once again?
Yeah. So E is basically, you have seen that E is basically f of z hat. So over here, z hat is basically, I just write again, it is c into ax plus by plus dz. So I can write, and f is basically represented by this tan h function. So directly I can write E is tan h of z hat. So we are taking dE, first we are taking dE by dz hat. That is nothing but the derivative of tan h function. So if I just go to the next page, and if I take the derivative of tan h function, so I can write, first I can write E is equals to tan h of z hat. So which can be written as e to the power z hat minus, sorry, plus e to the power minus z hat, e to the power z hat minus e to the power minus z hat. So we have to take derivative of this whole thing. So if I just take derivative of this whole thing, it would be, first we have to take, first we have to write the numerator square, so that is fine. Then the numerator will be kept constant. We have to take differentiation of the, sorry, the denominator part will be kept constant. The numerator part will be differentiated. So what here, if I just differentiate this upper part, e to the power z hat will be differentiated, the differentiation output will be e to the power z hat only. For this particular part, for this minus e to the power minus z hat part, the derivative output dz hat output will be, first this minus will be carry forwarded. Now e to the power minus z hat would be e to the power minus z hat only. Now you have to take derivative of this power term, so it would be minus 1. So effectively it would be plus e to the power minus z hat. So that is why you can see that I have written e to the power z hat plus e to the power minus z hat. So this plus e to the power minus z hat is basically coming from here. Then you put minus over here. Then the numerator part will be kept constant. Now we'll be differentiating the denominator part. So the denominator part's differentiation output is this one. You take the derivative of e to the power z hat, you will get the same thing. Now you have to take derivative of e to the power minus z. So e to the power minus z derivative, if I just take ddz hat. So over here, if I just take derivative of this thing, it will be same as e to the power minus z hat. Then we have to take derivative of this odd term. So then what we will get is a -1 will be getting. So this thing is minus e to the power minus z. So now you can see that this is making a square term. So e to the power z hat plus e to the power minus z hat square, then minus, and these two terms are same. So that is why they are making a square term. So you can see that if I just break it down, so it would be e to the power z hat plus e to the power minus z hat square divided by e to the power z hat plus e to the power minus z hat square minus e to the power z hat minus e to the power minus z hat divided by, obviously z is a square, and denominator also e to the power z hat plus e to the power minus z hat square. So you can see these two terms are same. So these two are cancelling each other. So that is why I have written 1 over here. And this thing, you can just take the common, you can take a common square. So that is why I have written like this, e to the power z hat minus e to the power minus z hat. And the denominator term is e to the power z hat plus e to the power minus z hat. So this is same as the tan h function. So that is why you get 1 minus tan h of z, and you take a square of that, and thus you get this one. Is it fine?
Yes, sir.
Okay. So the next question is, I'm just trying to join the meeting. So over here, you've been given the logistic function. So logistic function is written over here. So what is the name of this function?
Sigmoid.
Yeah, this is sigmoid. Now the sigmoid function, you can, the basic formula that you know, that is 1 plus e to the power minus x. Now over here they have written that wx plus b. So if I just first give you a glimpse of the sigmoid function. So you all know that how sigmoid function looks like. So if you go beyond this region, you will get almost equal to 1. If your value is residing in this region, it is almost equal to 0. And in this particular region, you will see a transition from 0 to 1. And over here, what will be the value at x equal to 0?
0.5.
Yeah, it would be 0.5. Now, if I do a linear approximation, so this is what kind of curve is this? Whether this is a non-linear curve or linear curve, the sigmoid activation function, is it a non-linear curve or linear curve?
Non-linear.
Yeah, so this is a non-linear function. And what I am going to do is basically I will be doing a linear approximation of this nonlinear curve. If you recall in your BTech first semester classes, there was a thing called diodes VI characteristics. So in diodes VI characteristics, there was a nonlinear equation, something like this. So the current increases exponentially. But there was another concept is that because diodes is a nonlinear element, we tried to do a linear approximation of this nonlinear curve. So the same thing I'm going to do over here. That thing was named as piecewise linear model of diode. So over here, I'm going to do the same thing. I will be doing the piecewise linear characterization. So for this particular part, you can see that this particular part is almost equal to 1. So it is almost equal to 1 over here, as because I am doing the linearization. Let me just strictly write that this is equals to 1. And this particular part is almost equal to 0, but I am considering that this is strictly equal to 0. And over here, you can see that this part is not exactly a straight line, but you can see the value is smoothly increasing in this particular region. And as I am doing the linearization, again, let me just consider that this part is strictly a linear curve. So that whole nonlinear curve is now segmented in 3 parts. One part is strictly 0, one part is strictly 1, and this part is now a straight line. And this straight line, you can consider that this straight line is equated with this particular equation. That is, here y is equals to 1, here y is equals to 0, and here y is equals to wx plus b. Now tell me, in this particular equation, what is the value of slope? In this equation, what is the value of slope?
One.
Not 1.
0.5.
0.5.
Yes, sir.
No, not 0.5. So, I mean, what is the expression of slope over here first?
1 by 1 plus e power minus x minus 0.5.
No, see, your equation of line is this one. Your line equation is wx plus b. So what will be the expression of slope for this line?
Is it b by w?
Minus y1.
B by w, no. So let me just tell you. So slope is meant by dy by dx, right? So you do dy by dx. So then you will get dy by dx is equals to w. Is it fine? Is it okay?
Yes.
Okay. So pretty straightforward that we know that slope is basically change in direction of y divided by change in direction of x. And that is basically we write in terms of y1 minus y2, x2 minus, sorry, y2 minus y1, x2 minus x1. So that means it will be written as by delta y by delta x. And if this delta is infinitesimally small, then I can take limit this delta to be very small. So then this whole thing would be converged to dy by dx. And that is why this particular thing, this was called slope, and same as this will also be called as slope. And that is why we have we have written that we have to evaluate the dy by dx to get the slope. So you can see that the slope value is w. So now tell me, if I just increase the value of w, so that is what they have written. If I just increase the value of w, so what would be the effect in this particular line? What will happen with this line? How the line will look like?
The slope will increase.
Sorry.
Slope will increase.
Yeah, slope will increase. So so just tell me whether the line will look steeper or more flatter. What would be the effect?
Steeper.
Would it be steeper? Steeper,
Steeper.
right? Yeah. So if you increase the value of w, if your line was previously like this, now what will happen is your line would look more steeper. This is when you increase the value of w. So same thing. Now you can, if I just take another page. So we had linearized the model of the sigmoid function. So this is linearized sigmoid. And if I just now, here let's say w was equal to 1, and here I have increased the slope, let's say by 10 times. So how the sigmoid function will look like? It will look like this. It will be very sharp. That means we can see that the line has become more steeper. More steeper. So the answer that is basically decided over here is what would happen with the increase in W. So what would be the correct option?
Option A.
Yeah, option A would be the correct answer. As because it is pretty straightforward that we can see that the W basically represents the slope of the linearized model of sigmoid. So that means if we increase the W, that means the slope is increasing, and hence the slope of the whole sigmoid function will also increase. Now let me ask you another question that let's say you have a line over here. Let's say a line like this. Sorry. Let's say you have y equals to m. Now tell me how y equal to mx plus c will look like. In which direction the line will be shifted? Left, right?
Right.
Left.
Right. So one answer is right, another answer is left. So if it is left, then why?
Because C increases, then the straight line would shift it to left.
Yeah, so the precise, yes, it would be shifted to left. So the precise answer would be, again, mathematically you can write it as mx minus y is equals to minus c, and you can write x is equals to minus c upon m, and you can write y is divided by c is equals to 1. And now you can map that your intercept in the x direction, it would be now minus c by m comma 0, and at y direction the intercept is at C position. So that is 0, comma C, and that is why if I just join a line over here, this will basically this is the equation of y equal to nx plus 3. Is it clear now that why the line has been shifted to the left side?
Yes.
Okay. Now let me ask you another thing. Yes.
Sir, one question on the earlier sigmoid function. So
Yeah.
what we said is we actually did the linearization, but if we don't do the linearization, the function
Okay.
is 1 by 1 plus e to the power minus x, right? If x is say wx plus b. So if I just look at the sigmoid, the more the x is going to increase, it's going to tend towards 1, which means the slope is going to decrease.
But
Because
the question is instead of x now, we know that sigmoid is this function, but they have changed the equation of sigmoid only, right? They have written wx plus b. This looks like sigmoid, but the exact form of sigmoid is 1 by 1 plus e to the power minus x, but now the form is wx plus b. Now in this particular scenario, how your e to the power x will look like when w will be increased. Anyway, if you increase the value of x with this equation, your curve will tend to the value 1 only. If you go this side, the value will be 1 only. And similarly, if you go this side, the value will be 0 only. But the main thing will happen over here. This is almost the linear part of the sigmoid thing. Now they are asking that if I, instead of writing x only, if I write a equation of line, that is wx plus b, what will be the main change in this region, in this linear region? Because over here you can see that this particular part is almost saturated. There is no change, almost no change. If you take derivative over here, you will see that barely you will get any derivative value, and that is why you get the vanishing gradient, because derivative is almost 0. Similarly, over here the derivative is almost 0, but here some derivative is existing, as because this has some sort of linear characteristics, and that is why they have asked that if we increase w, then what will happen? It is not like if we increase x, what will be the effect of increasing x? Effectively, if you increase x, it will be 1 only. The question is, with respect to x, with respect to w, what will be the change?
okay.
Okay, so what I was telling is that this particular part. So is it clear that why the line has been shifted to left side?
Yes, sir.
Okay. So with this, now you can see that now if you increase the C value even more, then the line will be again shifted to this side. So the more you increase the value of C, the line will be shifted to more in the left side. Now over here in this particular sigmoid function, which has been written with this particular WSB form, so you have this B term over here. Now my question is, if you increase the value of B, so what will be the effective change in the sigmoid function? Is the question clear that you have another parameter B, and we have my question is, if you change the value of B, what will happen in the sigmoid function? which is probably the next question. Yes. What would happen if B increases and these are the options?
C. The center point of the logistic function moves to left.
Yes, because we have seen the analogy that the main thing is that obviously there will be saturation in these regions, that if you increase the value of x, the sigmoid function will be saturated to 1. If you decrease the value of x, then your sigmoid function will tend to the value 0. But the main thing is that main magic will be happening over here in this linear region. So if you do not employ any value of b, then the sigmoid function is centered around this 0 line. But if you increase the value of b over here, what will happen is that, as we have seen, you can consider this as a line, straight line. Now, if you increase the value of b, this particular line will be shifted over here. If you further increase the value of b, then the line will be shifted over here, and it will gonna look like this. If you further increase, then it will look like this. It will look like this. Likewise, that means the sigmoid function will be forced to go in the left side. So the center point of the logistic function will move to the left. So that is why we have seen that initially the original sigmoid function basically centered around the point 0 when you get 0.5 over here. But as you increase the value of b, the function will be shifted towards the left side, and hence you can see the center point is now shifted in the left side only. Is it fine? Any query? So I hope there is no query. So over here for your reference, I have done some MATLAB simulations. So for this MATLAB simulation, you can see that initially the equation is 1 divided by e to the power wx plus b. So we can do the simulation like this. We take w equals to 1, bias equals the b equals to 0, or bias equals to 0. So this will give you the equation 1 plus e to the power minus x. So this is the traditional form of sigmoid. So we can see that this center is over here, the value is 0.5, and you can see the curve is reaching to 1 over here, it is reaching to 0 over here, and the center value is around 0.5. Now, if you increase the value of w, so if you increase the value of w, initially it was, let's say, 1, I have increased to 3. So now you can see that the line is more steeper. And when you, and over here I have kept the w equals to 1, that means the slope I am not increasing, but what I am increasing is basically the bias term. So if I increase the bias term, initially we have seen that with bias 0, the center value is basically located at x equal to 0. But now you can see that the signal, the sigmoid function, in what was centered around this x equal to 0 line. So if I just write over here, so this particular thing basically denotes w equals to 1, b equals to 0, and this is the thing when b equals to 5, w equals to 1. So you can see that the new sigmoid function has been shifted to the left side. So this is another form of verification.
So, sir, does it mean that we have to focus on the e to the power, whatever is that function? That can be a variable, it can be a function. So, what happens to that variable uh, when there is a change to the variable?
Yeah, actually, effectively, you are doing that thing only when you are changing this value. So effectively what you are doing is 1 plus e to the power minus, let's say you start with any values, that is w equals to 1, b equals to 1, and then you plot the whole thing, you see that what is the characteristic, and then again you change the value of w. So over here your main thing is that anyway x has a range, x has a range of minus infinite to infinite. Okay, I shouldn't put close bracket, it will be open bracket. So x has a range of minus infinite to infinite. That is true because you will be plotting against x only. Now here the parameters are w and b. So you will be seeing the function in terms of w and b, and you will be changing the function, or you will be calibrating the function with respect to w and b, and then you'll be seeing that what is the effect in the signal. So that is what we are doing. But uh, doing that thing in an analytical way, that is difficult, because over here the whole thing is a nonlinear equation. So every time I have to I have to put the value in calculator and then I have to show it to you. So it is easier to do a linear characterization, and then with mathematics I can show you that if I consider this particular part to be a line, then what happens with line, that is analogous what will happen with the sigmoid function. Because it is difficult in many of the cases in signal processing, in any other mathematical point of view, you have seen that we prefer to the things to be linear rather than non-linear, because when non-linear things comes, the mathematics becomes more difficult. One expression is y equal to mx plus c. The line of equation is universal, but the moment you say I want to work with non-linear function, I can say you can work with x square, you can work with x cube, you can work with x to the power 9,000, you can work with x to the power anything. So now you can see the moment your exponent will gonna the value of the exponent will increase, the shape of the signal will increase, and so as the mathematics will become more intense over there. And to avoid that thing, what we do in many of the cases, in many of the nonlinear equation or nonlinear dynamics problem, what we do, we try to make a linear form of that problem, and then we try to make some analogy. So that is what we do over here. You have raised this exact point that we will be doing that thing only. And if you are doing simulation, that is possible. But analytically or mathematically in pen and paper, it is very difficult to show you that. Otherwise, what I have to do, I have to put the values and then I have to show that what is happening. Rather than doing that, we can take an analogy for which the mathematics is well strictly bound, and then we can show that what is basically happening with the function.
Got it. Thank you.
Okay. Okay, so this is the next question. So the next question states that you have three functions, h11x, h12x, h21x. So h11x looks like this, x12x looks like this, and we have to evaluate what will be the shape of h21. So there are three options. So what will be the shape of h21? So again, the thing is that it is quite difficult. For example, in final examination, if you might encounter a similar question like this. So over there, it is very difficult to plot this function, and then first you have to plot these two functions, then you have to take the negation of h11x and h12 of x. Then you can understand that it will be impossible that we'll be plotting everything manually and then you will see. So you have to use some sort of characterization process or some other means to get down to the final answer. So if I just start with h11x, you can see we know that what basically e to the power 1 plus e to the power minus x looks like. And now we can see there is a W term associated with this and a bias term associated with this. Fine. And we know that this is a sigmoid function and this is also a sigmoid function, y equals to 1 plus e to the power minus wx plus b. X has a range of minus infinite to infinite. And what is the range of y? What will be the output value of y? Its range?
0 to 1.
Yeah, it would be 0 to 1. So 0, 1. So for all these cases, because the function is sigmoid only, over here instead of writing x, you have written wx plus b, equation of line. Okay. Now from the previous question, we got new information that when you increase the value of w, your the sigmoid function will be more steeper, and when you increase the value of bias, the signal will be shifted to the left side. So let me now try to draw the H11. So this is y equals to 1, this is y equals to 0 over here. Now, as because we have bias value is 24, we can consider that our it might look like this. It may not be exact the same thing, but we can infer something that it is a left-sided signal. And now tell me, and let us consider this is steep enough. This should be very sharp transition will be there. And now tell me that this signal is located in which side? Either it is a left-sided signal, right-side signal. What is the property of this H12?
The right side.
Yeah. As because we can see that initially bias value was plus 24. So that is why the signal was left. Now over here, we can see that the bias value is minus 24. That means bias value has been decreased over here. And as because the bias value has decreased, so that means it should be a right-sided signal. So therefore, I can say that it might look like this. So this is what H12 X will look like. So this is a right-sided signal. So now we have to negate these two signals. We have to take the difference in between these two signals. So again, we have to draw some inference. So over here, we can see that most of the values are now saturated in both the signals. So if you take the difference in this particular region, the output will be almost equal to 0. Almost 0, as because we can consider that all the values are saturated to 1 for both these signals. So therefore 1 minus 1 will be equal to 0. So this is 0. Over here also you can see that most of the values are now saturated to 0 in both the signals. So it would be 0 minus 0. So again you will get 0. Now again the change that you will be able to see is in this particular region. Now you see that to take difference from here. So initially the value is 0, then the value starts increasing. Then you see that the value is now started decreasing. So that means it is something like this. Initially the value is increasing, then after some point the value is decreasing. So you are getting some sort of this kind of representation. So I can write it like this. So you can see that this is not the correct option. This is also not the correct option. This is the correct option. Please don't bother about that where the maximum will come, where the minimum will come, because as far as examination or any analytical method is being concerned, you will not be able to do it precisely. You have to do it in some other alternative way. So you can see that you first negate h11 with h12. Initially, the value will start increasing. After some point, you can see that this belly is now shrinking. So therefore, again the value will decrease, and again it will reach 0 at this particular area. So therefore, initially it is 0, then the value is increasing, the reference value is increasing, again decreasing, and then decrease to 0. So this is the correct option. Any query? Okay, so I hope there is no query. Okay, so this is a easy question. It is written that if you have f of theta. The theta is basically represented by x, y, z, and it is equated as x square plus y square plus z square minus 8. Then the theta naught, that means the initial values, that means x naught, y naught, and z naught is given as 1, minus 1, 1. So you are doing one step gradient descent with learning rate is equals to eta. So what will be the value of theta after one iteration? So this is very easy question. Just tell me that what would be the value. Just what will be the value of x1?
-1.
-1. Okay, let me just take once. So for x1, the equation is x naught minus eta into del f by del x. So we have x naught is equals to 1 and eta value is 1 multiplied with del f by del x. So it will give you 2 into x, and it has to be evaluated at the initial position. So that is when x naught is equals to 1. So therefore 1 minus 2 is equals to -1. Yes. So in this way, you can calculate the same thing for del f by del y and del f by del z, and then you can use the equation y naught minus eta into del f by del y, and z1 is equals to z naught minus eta into del f by del z. I think you can do it. Okay. So the next question is, consider a box which contains 100 balls with 30, 50, and 20 balls which are inverted as red, green, and blue respectively. And your friend peeps into the box and estimates that the number of red, green, and blue balls are this. So what is the cross entropy loss? So first tell me what is the equation of cross entropy loss? PCE loss. What is the equation?
Minus p of x into log p of x.
Yeah. So this is the P true, that is the true probability, and then you take log of the predicted probability. So over here you can see the values that have been given, they are in terms of absolute values, but we need the probability values, as because you can see that you have a factor 100, a total of 100 balls were there, and out of them 30 is red, 50 is green, and 20 is blue. So For the first case, your friend, your original probability or the true probability is 0.3, and what your friend basically predict is 50 is the correct 50 is what he has estimated. So the predicted probability would be 50 divided by 100, so that is 0.5. Then your second entity will be for the green ball. So your correct probability is 50 divided by 100. So that means 0.5. And your friend predicts that there are 25 green balls. So it would be the predicted probability would be 25 divided by 100. So that means 0.25. So you can write 0.25 over here. And the last probability is you can see that 20 is the correct probability. So therefore 0.2 and log of again your friend predicts that there are 25 balls only. So the predicted probability is 0.25. So if you calculate everything, you will get 1.7 as the correct answer. The answer is not that important. Just tell me that whether you are able to understand this particular line or not. Is it fine? Or I can again explain.
It's fine.
Okay.
Sir, one confusion on the previous to previous question. If we calculate, no, not this one, the next one.
Yeah.
Yeah, here we calculated x, which is fine, but for y, the value is going to be different, right? Because it's a minus one. This is minus one.
Let me check. Let me check. For y now. So del f by del y, it would be again 2 into y, and we have to evaluate the value at the original location, that is y0 is equals to -1. So we will get the value is -2. Now your y1 is equals to y0 minus eta into del f by del y. So your original y0 value is one second.
-1.
So so it is -1, and then you get +2 over here, so you will get 1. Is it fine?
Yes, sir, I got it.
Okay. Okay. So the next question states that you have a softmax function that is given over here. Now, the softmax function, what is the range? What is the, not range, what is the property of softmax output? What is the property of this BI?
Sum is equal to 1.
Sum is equals to 1. And why sum is equals to 1?
The probability.
Because it's a probability. So it has another property that is quite trivial, but we should write this one. So the probability value is greater than 0, and obviously it cannot exceed 1. So what we basically infer is BI is a probability measure. Okay. Now they have imparted another factor over here. in both numerator and denominator. So you can see that in our previous sigmoid function thing, we know that sigmoid function is e to the power minus x, but they have given wx plus d. So still the function was sigmoid, right? Similar way, in the similar way, they have imparted a new function called k over here. Even though they have introduced this k, the function has the same property. You can consider this k into ai to be modified ai like ai hat, and then you can again modify the equation di as e to the power ai hat divided by summation e to the power ai hat for all I. So now you can see that you are again getting this softmax function. So this is also softmax function. So the bi that you will get from this updated softmax function will also follow the same properties. These are the properties. Will follow the same properties that have been written over here. It will be probability measure. The value will be greater than 0, and the summation of all these bi's will be 1. So the question that it is basically stating that can B still represent the probability distribution only? So what will be the answer from the inference that we just have received? Will it still represent the probability distribution or not?
It will.
Yes.
Yes. So the logic is the updated function will also represent same nature as softmax. Hence, bi, let's say updated bi is bi hat. Over here, let me write bi hat. So bi hat will also have same probability properties, and therefore we can say that still bi can be bi can be representing the probabilistic informations or the probability distribution. So therefore, true will be the final answer for this particular question. Okay. So I'm just omitting this kind of questions. So this is very easy to calculate. I hope that we have done enough questions like this in probably week 6 or week 7, that we've been given a neural network architecture. The input, bias, and weight values have been given over there, and we have to calculate what is the output. So in this particular question, the output we have to calculate at this particular place at O3. So I hope you guys can calculate this one, right?
Yes.
Okay, so let's move to the next question, because these are straightforward questions. So I'm not going to waste time in these straightforward questions. I will give you the slide as well, so you can calculate the answers by your own. Okay.
Sir, you will upload this video, right?
Yeah, I will be uploading this particular PPT and video as well. I will be uploading the video as well.
Okay, thank you.
Yeah. So this question states that you have a loss function that is given over here, and the loss profile is basically plotted against the W value or the weight value. Now, if I just read the question, so the question is, you are interested in finding minima of this function. So the function looks like this. So what kind of minima is this one? If anyone can tell me. What kind of minima is this one?
Is global minima?
Yes, this is a global minima. And we can see that in this particular neighborhood, we have a local minimum. Now, your interest in finding minima of the function I, that is the values of W for which the function will take the lowest value. So that is our main aim, is to reach to the minima value. Effective, our desire is to reach to the global minima value in any deep learning problem. But in most of the cases, we are not able to reach the global minima. We start at local minima. Okay. So to do so, you run a gradient descent starting from a random value W0. So you run your gradient descent from this particular value. Then you have updated to this particular value, followed by you've been updated over here, and then you have now updated at this location. After running 3 steps of gradient descent, you have updated value of W as W3. Okay. So the question is, you have updated till this point, and you have a local minima around this region. Okay, you have updated till this point as W3. Sorry, you've been updated to this point. So this point basically refers to the weight value W3. The red dots in the figure show the value of W at each step. Actually, I have converted the figure into a binary image, so that is why you can see only white and black. So these were red dots. So they basically refer to the weight update points. These are the weight update points. You show corresponding value of loss function. Okay. Now, what will happen? What will happen if you run 4th step of gradient descent? That means this is the first step, this is the second step, this is the third step. Now you start running the 4th step. The 4th step. If you try to update the value W using gradient descent update rule, what will happen with the updated value W4? So they have given 3 options. Whether the weight value will be increased, that means W4 will be greater than W3, W4 will be equal to W3, and whether it is less than W3. What will happen?
Will decrease. W3 is less than W3.
Sorry?
W4 is less than W3. Will decrease.
Option C you are saying.
Yes.
Okay. Any other answers?
Sir, option B.
Option B.
Yes.
Why?
Because the loss function is not changing its state, so there is no gradient there.
Yeah. Okay. So option B is the correct answer, and why he has pointed out the correct thing, that W4, the update equation will be W4 is equals to W3 minus eta into del LW by del W. Okay. And the value is evaluated at W equal to W3. Over here, you can see that after the third step, you are now at this particular position, currently you are in. And from this point, you have started doing the 4th gradient descent update. This you are started doing the 4th update. Now you can see that almost you are getting a straight line over here. And if you have a straight line like this, a horizontal straight line, and you try to evaluate the value of gradient at this particular line, you can see there is no change. So del L by del W will vanish to 0 because there is no change in slope in this particular region. So therefore, the gradient value will be equal to 0. So therefore, this particular term will be vanished. and therefore W4 will be equal to W3. So if you just run a gradient descent, your value will not gonna change, as because there is no change in slope, and therefore the value of W4 fourth update will be same as W3, and hence your learning will be stopped. So that means now you are trapped in a local minimum, is it not? So another information is trapped in local minimum. So to avoid these kind of conditions, that while doing the backpropagation or gradient descent based update, let's say you have trapped in a local minimum, what is the remedy for these kind of situations? What is the remedy? What do we generally use? So we actually use, yeah, I think someone has turned on their mic. You can answer. So we generally use optimizers. So there are several optimizers are there: momentum optimizer, atom optimizer, RMS prop optimizer. And this particular question, so the previous question was simple gradient descent, and now the question is for the optimizers. And the optimizer that we are using over here is a momentum optimizer. And the equations have been given over here. Now the same question, you did the gradient descent, first step, second step, third step. Now you do the fourth step, and now what will happen with W4? Whether it will be greater than W3, same as W3, or less than W3? What will happen?
Will increase.
Increase.
Yes.
And what is the reason behind it?
Because it will take the momentum, so T minus 1 will have an impact.
Yes. So the update equation, probably the font is very small. So update T is equals to gamma multiplied with update T minus 1 plus gradient of WT, and WT plus 1. So over here the T plus 1 is 4, who's equals to W3 plus update T over there. So now you can see, even though this update T equation have been written over here in the previous equation, so in the simple gradient descent we just had this part. So over here you can see that if you take the gradient, because no slope change is there, so again it will be vanished to 0. But you can see that you are deciding with another term, that is update T minus 1. So previously this update T minus will come from the third step, and in the third step we had a finite update, and therefore there will be some value, and now this value is multiplied with gamma, which is again a value which is greater than 0. So therefore W3 will be plus into gamma into update T minus 1, as gamma is greater than 0. So over here if you multiply with this thing, so that will be also greater than 0. And therefore if I consider that this value is, the previous update was finite, so therefore if you multiply this gamma, so this value will be greater than 0. And now you are adding W3 with something which is greater than 0. So therefore the value will increase, and we can say that W4 will be greater than W3. This is the reason why option A is correct. Yeah, this is also fairly simple question. Suppose you choose a model f of x is sigma wx plus b, which has two parameters w and b. Further, assume we are trying to learn parameters of this model using 200 training points. That means number of training samples or training, let's say we are doing image classification. Let's say number of training images equals to 200. And we are using a batch size of 10. Batch size of 10. So how many times each parameter will be updated in each epoch? So what will be the answer?
20.
20.
Yeah, 20. So the reason being you have 200 images. Now you have constructed a batch. In each batch, there will be 10 images. So a total of 20 such segregations will be there in a epoch. So let's say a epoch is going on. In a epoch, in each and every iteration, in iteration 1, let's say this is iteration 1, it will be fed to a deep learning model. Then it will calculate the loss. This is loss 1. It will be sorry. So it will calculate this loss 1, and then it will update the weights and biases of this model using gradient descent. Then in the second iteration, the second batch will go, it will calculate loss 2, and again it will update the weights and biases of uh, M or the model. So as because we see that there are 20 such segregations are there, so that means 20 times the data will be fed to the model, and therefore 20 times loss will be calculated, and therefore 20 times the gradient will be backpropagated to update the weights, and therefore we can say that uh, uh, if the question is how many times will each parameter will be updated in each epoch, as because in each epoch we are feeding the data at 20 times and 20 times updates is happening, so option B will be the correct answer. Okay. So you've been given a matrix over here, and you have to find that which of the following vector is not an eigenvector. So what would be your approach? Just tell me that. Whether you will be evaluating the eigenvalues, then eigenvectors, what will be your approach? Yes, anyone? Yeah, how you gonna proceed for these kind of questions? So let me tell you that you can do this thing a minus lambda into I, then take determinant, then you can take equate it with 0, then you will get lambda 1, lambda 2, lambda 3, and then you can solve, you get the eigen vectors, and then uh, you'll get the eigen, sorry, these are eigenvalues, and then you can get eigenvectors. But is it the best way to solve this particular question? So just tell me that how many of you will be following this particular path. You can raise your hands. Where you'll be calculating the eigenvalues followed by eigenvectors. Okay. So let me tell you that this particular thing will take substantial amount of time to calculate. First, you can see that you have a 3 by 3 matrix. So 3 by 3 matrix, you have to take determinant. You will get a characteristics equation which is of order 3. So that means you have to solve a equation which is of order 3 characteristics equation. You have to solve, then you will get 3 eigenvalues. And as because you get 3 eigenvalues, you have to calculate the eigenvectors 3 times. So you can understand that it will take huge amount of time. Instead of doing that, the correct approach should be, we know that eigenvector has a property. If A is the matrix and X is the eigenvector, what you will do, you multiply A with X and check that whether it is satisfying this particular relation or not. Whether it is scaled by some, the output will be, if you multiply A with any of this is A, and let us consider these are the possible eigenvectors. So x1, x2, x3, x4. And you check for all the cases, ax1, whether it is some constant multiplied with x1 or not, ax2, lambda 2, x2 or not. And let me tell you, it will not take much time. Why? Because you see, you have a 3 cross 3 matrix and you are multiplying with another vector with 3 cross 1. So output will be just 3 cross 1. You just have to calculate 3 values. Whereas over there, you have to take determinant, solve a equation, get values, then you have to get vectors. So it will be the easiest way to check. So if I just show you once, let's say for this one, probably it is not the eigenvector 1, 2, 1, 2, 1, 1. So let me ask you to do the same exercise. I am doing this A multiplication with this option A. Some of you multiply A with B, and some of you multiply with A with C, and some of the else you can multiply with A and D, and check whether which option is basically satisfying this relationship, and then you can tell me that what is the correct answer. So please do the exercise. Some of you can multiply with B, some of you can multiply with C, and some of you can multiply with D, and I am multiplying with A. So let us check 1, 1, 1. So it would be like 1 plus 1 plus 2. It would be 1 plus 2, 2, 4, 4, 4. So you can see that 1, 1, 1. We have got the correct answer. This was the vector. This was A into X. And
Sir,
after multiplication, sorry,
we cannot see your screen.
you cannot see the screen. But I'm sharing the screen. Others, you can you see the screen?
No, sir, it is black fully.
Black. Let me answer
I
and
can
then again share.
I can see.
Can you see the screen now?
Yes, yes.
Yes,
Yes,
sir.
sir.
Okay, you can see the screen, right? Okay. So what I was doing is, so this part, have you understood or not? This This part
And
where you
understood.
have to, okay. So what I had told that this part is very rustic to do. So we'll not do that thing. We'll use this particular property that eigenvector is such a vector. If you multiply any transformation matrix with that eigenvector, it will be the same thing scaled by some particular eigenvalue. So what I had suggested is you multiply this A with all of these options and then check that whether you are getting some sort of representation like this or not. And I tried with option A and I got that I multiplied with A into X, and what I got is basically 4 into X. That means it is satisfying lambda into X property. And so therefore this X1 is an eigenvector. So have you tried multiplying with any other cases? 1, 1, 2, 1, 2, 1, 2, 1, 1. So I'm multiplying with option D. So you can do with other options. Option D and C, please try it at your side and then tell me whether you are. Our main goal is to see that whether we are getting some sort of representation like this. So this is a scalar value. If I just multiply like this, it would be -1 plus 1 plus 0. Then it would be -1 plus 2 plus 0, -2 plus 1 plus 0. So I can write it as 1 minus 1 is 0, -2 1 as 1, and this as -1. Have you tried with option B? Anyone?
Yes, sir.
So what is the multiplication answer when you multiply with option B?
1 minus 2, 1.
1 minus 2, 1. So that means you see that you are getting the same thing, that is ax into lambda into x, and over here lambda value is equal to 1. So that means this is also an eigenvector and this is also an eigenvector. What about option C? Anyone has tried with option C?
1, 0, minus 1.
1, 0, -1. So now if I just elongate this particular expression, 1, 0, -1, I can write this thing as -1 multiplied with -1, 0, 1. Is it not? From this thing, I can write it like this. So I can write that lambda into x again. So this thing is also an eigenvector. But you try with option D, which I have tried. So when I multiply with option D, you can see that I have multiplied with this and I got this particular thing. I cannot do any operation so that I can get lambda into x format. I cannot do this because you can see that option D, the initial x vector, this x vector, the last entry was 0. But over here, after multiplication with A, this side, the first entry is 0. So I cannot get the same representation. So therefore, I cannot get lambda into x format. So this ax into lambda into x. So this thing is not valid for option D. So therefore, option D is the correct answer as it is not an eigenvector. This is pretty easy. You just have to calculate a bit fast. Otherwise, if you just choose this particular method, you can understand that you have to first solve an equation, get some values, and then you have to do the corresponding calculations for eigenvector. This will take lots of time. Around 5 to 6 minutes it will take. Okay. Let's move to the next question. Which of the following set of vectors does not form a valid basis? So what do you mean by basis? This thing we have covered probably in week 1 quiz. What is meant by basis? Basis basically means the vector quantities which are linearly independent with each other. And what is the mathematical form of linearly independence? What do you mean by linearly independent vectors? Set of vectors. Let's say you have V1, you have V2, and V3. Then how we gonna say that these three vectors are linearly independent? There is a mathematical form is there. So the form is, you take linear combination of these vectors a1 v1 plus a2 v2 plus a3 v3 equals
So
to
we
0.
can
You
look at
equate to 0.
covariance matrix, right?
No, not covariance matrix. Covariance matrix gives you statistical independence. It does not give you statistical independence. It shows that, for example, if you have two quantities, let's say uh, A and B, let's say person's gender and profession. And if you see the covariance matrix, it will give you the relation between, for example, relation between gender and gender, relation between gender and profession, relation between gender and profession again. So it would be just the
So
relation between.
if the non-diagonal elements are 0,
So
these are
that basically signifies statistical, they are statistically independent.
okay.
This is
Okay.
not linearly independent. Whenever you see this term, na, linearly independent or anything with linear thing, the moment you see linear, in your mind, it should strike that it has something with linear algebra. At least in mathematical sense. Some linear algebra must be involved with this. You have said it correctly that it is also it also gives you some sort of independence, or if this particular value is 0, it will also give you some sort of independence information. But that independence information is basically a statistical point of view. From the statistical point of view, you can say that these A and B quantities are statistically independent, but not in terms of linear independence.
Okay, sir.
Okay. So you can take linear combination, and if you equate with that 0, with that linear combination, if you equate it with 0, it will only satisfy this particular rule when A1, A2, A3 are 0 in each. So on other words, that you can also say that if they are independent, then you cannot write them or represent them. It would be the correct word. You cannot represent them in any sort of linear combinations. That means you cannot do linear combination there. So over here also I have shown you that if you do the linear combination and if you equate with 0, this particular relation only valid as far as linear independence is concerned when A1, A2, A3 are independently 0. Then you can say that this is this linear combination could be 0. One easy example would be XYZ axis. So if I just show you the unit vectors of XYZ axis, it would be 0, 1, 0. It would be 0, 0, 1. Now you tell me, can you make any linear combination? Like, can you make something like this V1 plus V2 is equal to V3, or let's say V2 plus V1 is equals to V1? Can you do something like this? So these are some sort of linear combination. Can you do any of these operations?
No.
Sorry.
No, we cannot.
So you cannot do this. So therefore, any of them, let it be A, B, and C, any of them cannot be represented as linear combination of any other two components. So therefore, these are linearly independent. So I think you have my slides as well. You can go to week 1's probably question 7 or 8. There also we dealt with linear independence in great detail. So over here I am just skimming through about the concept. Over there we had given 2-3 examples, so you can refer to that as well. So the main thing is that we cannot do any sort of linear combination. Or if I do like this also, this A1, A2, A3, those things have to be 0, equal to 0. Then only this whole linear combination can be equated with 0. If A1, A2, A3 is any value other than 0, then you cannot say that this is a linearly independent set of vectors. So if I just show you the correct answer, so I had calculated it beforehand. Where So 2 into 1, 3, 1, 1, 3, 1, then 4 into minus 1, this into 2, and then you can write minus 6, 5, 4. And now if you equate this one, so what you will get? What will be the output?
Zero.
Yeah, so it would be 0, 0, 0. So you can write a big 0. So this is called zero matrix. So you can say that A1 is now 2, A2 is equals to 1, and A3 is equals to minus 1. So therefore, you can say that none of them, A1, A2, A3, none of them are equal to 0. So therefore, that form is not A1, A2, A3, B3 is equals to 0, and A1, A2, A3 should be equal to 0. This is the relation for, this is the theory for linear independence, and that is basically violated over here, as because you can see that you are getting some sort of scalar value other than 0, and therefore this set is not a linearly independent set. And if it is not a linearly independent set, so this cannot be a valid basis. As because in basis definition we have written that bases are those sort of vectors by which are linearly independent of with each other.
Sir, how did you solve that? Did you come up with 3 equations and came up with this answer?
Yeah, I used 3 equations and then I got this answer. The thing is that you will not, probably you might not see these kind of questions. So rather what you might see in examination, so you might be given these two vectors because it is very difficult to you might think that I have done a pretty good guess. Someone might think that I have done a pretty good guess, so that I chose 2, over here I choose 1, and over here I choose -1. So it is not that. I had equated with 3 different equations, and then I got the solutions, and then I got to know that this is the correct answer. But as far as final examination is being concerned, you might see something like that. You might be given A and B, and then in the option they will ask for the corresponding C, for which you might say that all these sets, that means A, B, C, are linearly independent or not. Then it is very easy. Then you have to see some sort of transformations that if I just multiply with 2, 1, something else, whether I can, whether I'm able to form anything like this or not. Then that is easy. So in week 1 quiz also, they have given you something like this. A and B they had given, and they asked that what would we see such that A, B, C all are linearly independent with each other. And then the pretty straightforward, in a straightforward fashion, in week 1 at least, you guys had solved that option A or option B was the correct answer, because the transformation, this scaling factor are pretty easy there, because in examination, because it's a MCQ examination, they will not give you something which is very difficult to guess. But as far as this particular question is concerned, that is why I told that I already have pre-computed the value and I have the answer. Otherwise, if I just try to solve it down, I have to solve several equations to get this particular relation, that is A1 is 1. I think it's fine now.
Yes, sir.
Okay. So the next question is, you have a square matrix A R3 cross 3, and you have a property A transpose is equals to A. So what kind of matrix is this one?
Sir, I'm not seeing your screen, sir.
Sorry?
The screen is not visible for me. Your face only is showing.
Others can see the screen or not?
Yes, it's visible.
Okay, probably at your side some internet issue might be there. You can leave the meeting and then again try to join the meeting. Probably
Okay, sir.
this will resolve the issue. Okay, so those who can see the screen, please tell me that if A transpose is equals to A, then what kind of matrix is this one? Yes, anyone?
Symmetric.
Yeah, this is a symmetric matrix. Okay, so let me read out the next part of the question. My friend told me that these 3 vectors are the 3 eigenvectors of this matrix. So that means you have A, which is a symmetric matrix, and your friend told that he had evaluated V1, or let's say they have given the name X, Y, and Z. These are the eigenvectors. So the question is my friend telling truth or not? So how you can solve this? So what do you think that what could be the possible answer? Or can you recall any sort of properties? You have a symmetric matrix, you are extracting eigenvectors from that symmetric matrix. Anywhere in any lecture, any topic was covered, something like this symmetric matrix based eigenvector extraction. Then you can recall some properties were there. Okay, let me give you a hint. You know that this is a symmetric matrix. Tell me, what is the property of covariance matrix?
Is symmetric.
This is symmetric matrix. Now, if you have a symmetric matrix and you had extracted eigenvectors from a symmetric matrix, in which topic? If you can recall. In autoencoder chapter. Now, if you can recall. So in TCA, you had the covariance matrix, and then you had extracted the what you call eigenvectors from the covariance matrix. And the eigenvectors are named, what are the names of those eigenvectors in TCA?
Principal components.
Yeah, those are called principal components. And what is the property of principal component? If let's say A and B are principal components, what does the property that they hold?
They would be orthogonal to each other.
Yeah, so they have to be orthogonal to each other. And even, and let's say A, B, C, there are three principal components. So A should be orthogonal to B, B should be orthogonal to C, C should be orthogonal to A. So this is the property. So now, can you relate this thing, that what inference I gave? Can you relate this thing with this problem? And now can you tell me that whether the friend is telling truth or not? So the inference is, over here, you can see this is a symmetric matrix. Okay. And your friend is telling you that he has extracted eigenvectors from this symmetric matrix A. So the eigenvectors that he has extracted, we know that from a symmetric matrix, if you evaluate eigenvectors x, y, z, then they have to be mutually orthogonal with each other. Orthogonal with each other. And we have to check, and as because your friend is telling that x, y, z are these orthogonal vector, these eigenvectors. So now let's check whether x is orthogonal to y or not. How can we check whether x and y are orthogonal to each other or not? Is there any mathematical operator is there by which we can understand two vectors are orthogonal? Yes, anyone?
Dot product.
Sorry?
Dot product.
Yeah, dot product. So dot product should be what?
Cos 90 0.
Yeah, it should be 0. So let's check whether the dot product is equal to 0. So -1 multiplied with 1, it would be -1 plus 1 plus 1. It is not equal to 0. So that means x is not orthogonal with y, and therefore it is not satisfying the conditions or the properties which the eigenvectors must obey if it is extracted from a symmetric matrix. We know the eigenvectors extracted from symmetric matrix are orthogonal with each other. However, we can see that x and y, where your friend has told that it is a where he is telling that these are the eigenvectors extracted from a symmetric matrix. It is not following that x is perpendicular with y, and therefore we can say that your friend is telling something which is not true. So in this way, you can refer to the final answer. So any query?
Sir, can we take an example here and go through it?
Actually, if I can show you. One second.
And sir, that symmetric matrix can be identity matrix as well, right?
Yeah. Yeah, it is an it is a symmetric matrix, but over there, it will be the identity, the vector will also be identity for which you will get the eigenvector. So let me just show you, because let me just take some other solid examples. So eigenvector of symmetric matrix array. If I just ask ChatGPT, he will show. Is a symmetric matrix, and then extract the eigenvectors with mathematical examples. So it has given you the eigenvalues. Extract the eigenvalues for each eigenvalue. They're not giving you the solution. Because it will take time to solve that thing.
That's okay, sir.
If I just do this, I think I have one example. If I have it over here, then I can show you. Otherwise, what you can do, you can take any any symmetric matrix, and then you can do the computation, because it is in the property of symmetric matrix that the eigenvalues of symmetric matrix will be orthogonal to each other. And over here in this particular problem, had it been a orthogonal set of eigenvectors, it would be a symmetric matrix, but here the property is not satisfying. So I think if I just go here, DSP week 1, and this is the annotated one. Sorry, I don't have that in my personal copy. I might be having that thing. What I will do after this class now, I will upload this thing, that one particular example in the forum. So from forum, you can download that particular thing. Okay. Just for the verification part. Otherwise, this is a property of symmetric matrix. This question was actually
Sure.
framed in mid-semester. Sorry.
Yeah, I said sure, sir. The only question I had is when we talked about PCA, I don't think we talked about symmetric matrix when we talked about the PCAs orthogonal to each other.
Yeah, we talked about. Yeah, we actually talked about that. 1 second. I had that. Can you just tell me in which week PCA was explained?
I think week 6 or 7.
Okay, with solution of PCA. Yeah, if I just go here now, I can show you the answer. This is PCA. Yeah, so over here we solved a question which basically A and B are two vectors, and they are forming principal components. So there we had to find what is the value of n. So if you go to my week 8 live session na, so you will see that we had talked that covariance matrix is a symmetric matrix, and the eigenvectors of the symmetric matrix are orthogonal to each other. And there, in that particular video, you will find a detailed discussion about that, how the covariance matrix has to be a symmetric matrix, how the eigenvectors are orthogonal to each other. In that particular video, you will be getting that information. So you can go again, you can refer to that video again. Week 8
Sure,
probably.
sir. Sure.
Sorry, week 7, sorry, week 7.
Okay, we'll do that. Thank you.
Okay. Actually, the materials are kept in a scattered manner. So some of the materials are in my laptop, some of the materials are there in the college PC. So that's the difficulty. Next question is, a model is having high bias and with very few parameters. So what could be the scenario over here? Either it's a underfitting case or overfitting case. A similar discussion we had in one of the week's quiz as well, where the model capacity was not good. So there we had something similar question. like this one.
For
If
high
your
bias,
model has very few parameters, then what is gonna happen?
it will not generalize.
It is not generalized. Not generalized. So if your model is not able to generalize the information from the data, so what kind of problem is that one? Whether it's an overfit or underfit, or what is that kind of problem is called if you're not able to generalize the data?
It will overfit. It will just memorize the data.
And what about high bias?
High bias means overfit.
No, over here, let me show you. And generalize is not the correct term actually. Let me show you that what will happen. For example, so first tell me whether this problem is linearly separable or non-linearly separable.
So non-linear.
It's a non-linearly separable problem. Non-linearly separable problem. Now, high bias means, first let me talk about very few parameters. Very few parameters in a deep learning model. Why the models have been made deep in successive years? That is, when you use deeper models, it will have higher number of parameters. Then your model will be able to extract good features from the image, and then your model will be able to do good classification. So that means when you have higher amount of parameters, then your model, you can say that your model is an intelligent model. But the thing is, when your model is having very few number of parameters, that means your model is not intelligent. So you can say that your model is a dumb model. And a dumb model cannot extract good amount of features or good representational features from an image. And if you use those images, your model will not be able to classify with a good accuracy. That is what happens in case of very few parameters. Your model is dumb, it is not able to extract good features, and therefore it will not be able to classify properly. That means what is basically meant by it is not able to extract good features? That means it does not capture the information, it does not capture the information from the original data or the training data that you feed to the model. So let's say if your model would be a complex model, and these are the two classes, your complex model can draw a boundary like this, but your dumb model will try to do something like this. This is what your very few parameter model will do. So this is what happens with very few parameters. Your model is not able to extract good representational features, and hence from these two cards, can you identify that what sort of problem is this one? Had it been a good model, it would have it might have done some mistakes in classification. It might not be exact circle with 100% accuracy. It might be something like this, and another case is like this. So what this case basically refers to?
Underfitting.
Yeah, this is underfitting. in probably in week 11th or week 10th week, we there was a quiz question was there. What kind of measure we should take when we see that underfitting is there? So there the correct option was we need to increase the number of parameters of the model. So over here you can see that very few parameters basically uh, increase the problem of underfitting. As because if you increase the number of parameters in the model eventually becomes smarter, and therefore the feature or the feature characteristics, it will be able to capture it nicely, and then it will do the good classification. However, in case of underfitting, model is not able to extract good features, and hence it is not able to uh, create a good boundary over there in between two classes. It is just a random boundary. And what about high bias? High bias is basically you have preconceived notion, preconceived notion that your uh, data is linearly separable. When your model has high bias, no, so that time what the model basically thinks that whatever data you feed, it thinks that your model is linearly separable. So even though you can see that the data is non-linearly separable, with high bias means it considers that whatever data you give me, it will be non-linearly separable. So I just have to draw a straight line over there. So over here also you can see that your model is not able to classify well. It is just putting a straight line for the non-linearly separable problem as well. That means your model is not able to capture enough information from the data, and hence again the problem of underfitting is basically residing. So therefore underfitting is the correct answer. Rather, if it is overfitting means that for this particular problem itself, if I just draw it again now, this is a good fitting. So in case of good fitting, you can see that some misclassification is there. Some of the greens have been misclassified as the red one, because the classification boundary basically contains some of the green samples as well. So good classifier will make a generalization. But in case of overfitting, what will happen is that your model will strictly memorize everything, and it will create a very nice boundary, very compact boundary. That means it has memorized everything, so it knows that where is the location of the feature, and therefore you can just create a very compact circle over there. So this is what memorization means. So in case of memorization, in training set, you will get 100% accuracy, but in testing set, you might get 30% accuracy. But in this case, the good generalized model, even though it has done some mistake, but it has captured some representational properties about the different classes. It has not just memorized everything. So this model, if you just deploy in your testing phase as well, you might see that it is giving around 80%, 85% accuracy. So this is what underfitting means. This is what overfitting means. And this is the general uh, model training, what looks like a good generalized model looks like. Okay. So the next question states that is the following statement true, that a complex model will be more sensitive to changes in training data than a simple model? Is it true or false?
False.
Sorry,
False.
how it is false? See, a complex model is very intelligent. Main thing is that whenever you see complex model, you should have you should have a preconceived notion that a complex model is a model which can give you the best result, best generalized result. So whenever you see a complex model, you can think that this model is very intelligent and it works way better than any simple model or low parameter model. So whenever you see a complex model, you can see that the statement is stating that a complex model is more sensitive to changes in training data. More sensitive means, for example, if you have been given a classification like this, classification task like this, if I just show you week 1. Let's say you have been asked to classify these two images. In bare eyes, in naked eyes, just tell me that doesn't it look alike, these two images? Matlab, these two animal species look alike.
Yes.
It looks alike. In naked eyes, both of them will look like deer only. But the actual class label is enabled and redbug. And if you ask a simple model to classify these two images, as because it will see that, oh, there are almost similar information. So what it will do, it will not be able to classify properly. So that is what basically meant by the sensitivity. But if a complex model will see, for example, a complex model like ResNet 18, BGG 16, when those sort of model will see these two images, and if you train these type of data using BGG 16 or ResNet kind of model, which are very complex in nature, then you'll see that you might get very high accuracy. You do transfer learning, you even get higher accuracy. Why it is happening is that these complex model, as because they have learned so many parameters, they become very intelligent. Then they understand what is the changes to, for example, there must be some changes to classify this image with this one. So then you'll see that with complex models such as BG16 ResNet, you'll be able to classify these two classes very efficiently rather than if you choose a very simple model like SVM, KNN, something like this. So that is why a complex model is very much sensitive in changes in the training data. Another example, if I show you, I had showed this one in my first class itself. So here also the signals quite look alike. There is no this just looks like a noisy signal. But this signal belongs to a healthy class. This signal belongs to asthma class. Many people, because my research area is this one, lung sound based pulmonary disease detection, disease progression monitoring, these things. So in many papers which came around 22, 21, this time, many people, what they did is basically they expected some feature and trained simple models like SVM, KNN, like that. They got 80% accuracy, 70% accuracy over there. What was missing is that these simple models are not able to characterize these uh, signals, which looks kind of alike. Both of them kind of look alike because this is just a random noise only. And what we propose is we propose different sort of architectures, different sort of learning mechanism using deep learning only. We used contrastive, something called contrastive learning. We modified the architecture of convolution in CNN networks. And then we showed that our model now it is able to capture very good properties of the different classes. And it was able to classify with higher accuracy. So that is what happens is that when you do use complex model, it is able to capture more sensitive properties of the training data rather than what a simple model can do. So therefore, this option is true. This answer is the statement is true.
Got it, sir. Thank you.
You have so from these three figures, just tell me that which is the best suitable training. So over here you have training scheme 1, training scheme 2, and training scheme 3. So which model, let's say this is model 1, model 2, and model 3, which model is trained well? From the training card, if you can tell me. You have training loss and validation loss. Second one, yes. And what is the problem with 1 and 3? Whether it is an underfitting problem, overfitting problem, what is happening?
It is overfitting.
Yeah. So both of them, you can see that there is a high margin between the validation and training, and over here also there is high margin between validation and training. So that what it means basically in training, the training scenario, your model is performing better, but while doing the testing, you have substantial amount of loss. Over here also, your model is doing well in case of training phase, but when you do validation or some sort of testing, you can see that your model yielding very high loss value. So therefore, these problems are overfitting. I have so many questions. I can give. So this is also very simple question. So you have this image, and you have this is image I, and this is a filter. Let's say kernel of this sort. So can you tell me that what kind of output you will get, whether option A, option B, C, or D? First, tell me the property. Can you see any sort of property from this particular filter? So the property that it has is, if you just see -1, 2, and -1 now. So if I just see this particular column, you can see the transition is very sharp. So let's say you have -1 over here, -1, then suddenly you get a jump of 2, and then again you got a sharp transition of -1. So when you see any sharp transition in any signal that has something called high frequency information. Frequency means what? It is basically, for example, this is a sinusoid. So over here, if I just show you what basically the high frequency sinusoid looks like, you'll see this kind of thing. So you can see that very rapidly you are getting these transitions. So over here also, you can see you got -1, you got sudden increase in value, and then again sharp transition. So you can see over here also you are getting sharp transition in case of high frequency signal. So that means any high frequency information, so this particular thing contains high frequency information. And in case of images, high frequency information, high frequency information is embedded in edges. So edges or boundaries. For example, in your mobile phone also, if you take a picture, if your camera quality is not good, you will see that, for example, 2-3 people are there. For example, let's say you are using portrait mode, portrait based blur mode. So when you click picture, if your camera quality is not good, what will happen is that, for example, if you are blurring the background of mine, so if your camera quality is not good, along with the background blurring, you'll see that some of the boundaries will also be blurred. And boundary contains the information of high frequency information, because why high frequency? You can see that in my facial for example, in my facial boundary, whatever information that I have in the just after the boundary, the information is quite different. Over here, the information is uniform, but just after the boundary, you see something which is abruptly changing. For example, even if I just show over here, this is a boundary. So in this particular boundary, you can see you get something uniform over here, something uniform over here as well. But at this particular junction, there is a sharp transition from white to something which is very dusky. So over there, boundary, so that means you got another sharp transition. You get sharp transition in the boundaries of any image. So boundaries basically contains the high frequency information. And this particular filter has also got something to deal with this high frequency information. As we can see that there is high transitions are there, and you can see how this the constant values have been aligned. These constant values have been aligned in the horizontal direction. So that means indeed this particular filter has got high transition properties, and as well as these values have been, this -1 value have been placed in a horizontal fashion. So that is why this type of filter is called horizontal edge detector. So the output, if you feed this kernel over this particular image, you will see that the horizontal edges will be prominent. So it is a horizontal edge detector. So you will see the horizontal edges will be highlighted. So from this particular information, so what could be the best answer for this one? You have to see that in which of the answer you can see the horizontal edges are more prominent.
A.
Yes. So option A will be the correct answer, as because you can see in this particular answer, you can see the horizontal edges are more highlighted than this one, this one. This is totally different. This is the output of vertical edge detector, vertical edge detector. In CNN lecture week, you can see these kind of operations have been taught, but there the kernel operations were not told. So this image I have taken from an image processing course. I thought that in CNN you might see some questions like this as well. Okay. I have few more
Sir,
questions.
what is the significance of 2 there in that kernel? What if I have say 3 or 10?
Okay, so this basically shows that what is the intensity of the magnitude. So the more is the intensity of the magnitude in this particular location, what will happen is that over here the amount of whitish thing that you can observe in the edges, that will be even more prominent. So this basically ensures that whatever edge it has been detected with how much illumination it has to show. If this value will be more, then over here these edges will be more prominently detected.
And -1.
-1, this basically ensures that it has to show that in some way there are high transitions are there. For example, -1, if it could be -2, -3, anything, but it has to show that there is high transition is there. For example, 1, 2, and -1, you can see that you got something negative value. Suddenly you jumped to a value which is 2, and which is a jump of uh, 0, 1. So that means 2 unit you have jumped. Actually, 3 unit you have jumped. So this basically shows you a property that this has something to deal with high frequencies, because in high frequency we'll see the sharp changes, and these same sharp changes in images are basically reside in the edges and boundaries. And I gave you an example also. For example, over here the information in this particular region is quite uniform. Over here also the information is uniform, but at the boundary there is a sharp transition between these two colors. So over here the high frequency information resides. You can consider these kind of images as well. Let's say you have a mountain, and over here some green areas are there. So at the junction, it will have over here the information is quite uniform. Over here the green information is quite uniform. But main thing is that at the edge, there is a high transition from, let's say, brown color to green color. So that means it has high frequency information over there. And this also basically gives you an information that you have a high frequency that you have to capture.
And sir, how do we decide it's a horizontal edge detector and not vertical?
Yeah. So you have to see that these minus values, basically in most of the general cases, we use minus values to represent that these are the locators of the high frequency information. So the way these minus values have been oriented, so for example, if these are oriented in the horizontal direction, then we'll say that this is a horizontal edge detector. And had it been placed like this, -1, -1, -1, 2, 2, 2, and -1, -1, -1, then you would have called it a vertical edge detector. And if you apply this vertical edge detector to this particular image, then you would have get this output. Here you can see that vertical edges have been emphasized, and this particular filter will do the vertical edge detection, as because these -1s are basically the locators of the high frequency information have been placed in the vertical direction.
Understood, sir. Thank you.
Okay, so these are also very easy questions. So you can see that you have a kernel 7x7 and your image size is 9x9, but you have not been told any padding and stride. So if you encounter any sort of question like this, you have to consider that padding is 0 and stride is equals to 1, because that is what is the convention. In any coding platform, MATLAB, be it MATLAB, KDAS, or PyTorch, we consider that if we just declare the kernel size and image size, and we do not declare the other parameters, the by default parameters are these two. So don't get confused that what would be the value of stride, what would be the value of padding. So over here, 7 minus, it would be 9 minus 7, because the image size minus kernel plus 2 into padding divided by stride plus 1. So over here it would be 2 plus 1, that is 3. So therefore 3 cross 3 is the answer. So you have to be careful about this. You should remember this point. If you've not been given any information about other parameters, the parameters are such that p equals to 0, s equals to 1. Okay. So in the next question, you have 128 cross 128 cross 3 image. You have applied 6 filters which have size 9 cross 9 cross 3. What will be the dimension of the output volume if stride is equals to 1, padding is equals to 2? So padding equal to 2, stride equal to 1, your input size is 128, and kernel size is 9, number of filters is 6. So what will be the output size? Anyone? So 128 charge. So 124. So one spatial dimension will be 124 cross 124. What will be the channel dimension?
6.
Yeah, so it would be 6. So therefore, 124 cross 124 cross 6. Okay. Batch normalization layer does not introduce any new parameter. Is this true or not?
It is false.
It's false, right?
Yeah.
Are you saying false?
I'm saying false, yes.
Yeah, so this is false because we have two parameters, that is scaling and shifting, beta and gamma. So these are the two trainable parameters of batch normalization layer. So we have new parameters according to as far as batch normalization is concerned, and they are saying that this layer does not introduce any new parameters. So this is false. Again, so the next question, we can use backpropagation to a deep neural network only if all the hidden layers in the network have same activation. So do you think this is true or false?
This is false. We can have any activation.
Yes, we can have any activation. For example, in layer 1, you can use ReLU. At layer 2, you can use GELU, CELU, anything, even Tanh. So you can use any combination of activation functions in the deep learning network. It does not matter that you have to use same activation function throughout the neural network. It is actually also a hyperparameter to a neural network that what activation function you choose. Because you cannot finitely say that ReLU activation only give you highest, GELU activation will give you the highest result. It is also a thing that you have to optimally set. Okay. So this is also a very simple question. So you have Maxout activation, which have been given over here. Now, how you can manipulate this particular equation such that you get a ReLU function? So the current function is max W1 transpose X plus B, W2 transpose X plus D2. Over here is DM. So how you can manipulate this particular function such that you get the ReLU function? What could be the suitable answer? What is the definition of ReLU? F of X is max. Yes, what is the definition of ReLU?
Zero.
0
And infinite.
no, it is 0 comma X. So if the value is in the negative side, then all the value will be 0, because let's say you put x equal to -1, so max of 0 comma -1 will be 0. But when you go to the positive side, you put, let's say, 0 comma 2, it would be 2 itself. If you put 0 comma 3, it will be 3 itself. So therefore the function is max 0 comma x. So now tell me that what sort of manipulation you can do such that you get max 0 comma x here. Yes, any guess?
B1, B2 equal to 0.
Let's say B1 is 0. So the equation will become W transpose X, W transpose, let's say W1, W2 transpose X. I have made B1 and B2 equals to 0. It is still not the same thing. You have to get one of the term has to be 0. So what you can choose is, you can choose that W1 is also 0. Then what will happen? Max of 0 comma W2 transpose X. Over here I forgot to paste another thing, that comma W2 should be equal to 1. So max 0 comma X. So option D is the correct option. Just include this one as well. W2 is equals to 1. I hope this is fine, right? Is this okay?
But even in the B1, B2 equal to 0, that's going to give us the results, right? Because if x is equal to 0, it's going to be 0. If it's x is greater than 0, we will get some value.
Max W transpose X and W2 transpose X, right? Let's say you put x equals to 0, right? So it will give max 0 comma 0 is 0. That is fine. Now let's say you don't know what is there in W1 and what is there in W2. Then let's say you do max, in both the cases you put -1. So it is minus W1 transpose minus W2 transpose. Then how can you ensure that you will get the same response as we are getting here? Because effectively for all the minus values, for all the minus x, whatever minus x you put, they have to be mapped to 0 value. But over here, this W1 and W2, let's say they are scalar values. They have some value, say let's say lambda and a and b. So then whatever is the maximum value that you have to choose. Then you will not get this thing, right? Am I clear?
Yes.
So for that logic, we have to get one value to be 0, which will ensure that if you put minus value over here in x, whatever maybe the value over here is coming, the final value should be, the final output of the function should be 0, such that you get this particular response. And to even make the thing more proper, this whole thing you can make 0 by putting W1 and B1 equal to 0, B2 equal to 0, and this W2 equal to 1. So then what will happen is that this term is 0, this term is 1 multiplied with x only. So this will give you 0 comma x, right? Okay. Yeah, this could be. So I think we can solve this particular question and then we can end the session. Consider the autoencoder, which has one input layer, one hidden layer, and one output layer. So the architecture of the autoencoder is like this, but we don't know that what is the dimension of the hidden layer. And the input x is of R10 cross 1. So x is R10 cross 1. So what is the dimension of this input layer? Yes, what will be the dimension of the input layer? Yeah, if your input is of 10 cross 1, so how many neurons you will have in the input layer? Yes, anyone? So you can think that x is having x1, x2, x3, x4, x5, dot 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 x10. So this is how x will look like. So that means you put x1, x2, dot 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 x10. So that means it has a dimension of 10. So what will be the dimension of output of the autoencoder?
Output will also be 10.
Yeah, output will also be 10. But I don't know what is the shape of the hidden layer. So let me write H. And there is a weight connecting every neuron in the input layer to every neuron in the hidden layer. Similarly, weight connecting to every neuron in the hidden layer to every other neuron in the output layer. This is we know from multilayer perceptron theory only. There is no bias. There is no bias. This is the thing that you have to keep a trust over here. So there is no bias in the network. Now, if the input is of shape 10, the total number of weights of the network is 160. So total number of weight equals to 160. So can you tell me that what is basically the total number of parameters in the encoder part and in the decoder part? What is the total number of parameter in encoder?
80 and 80.
Yeah, it would be 80. Easy guess would be 80 and 80, but let us go by the matrix multiplication property, that what would be the size of W. So we write now D cross D, something like that. So what would be those values? What would be the shape of W? It is easy. You have 10 number of neurons in the input and each number of neurons in the bottle or the hidden layer. So it would be 10 multiplied with H. And similarly, over here you have H number of inputs, H number of neurons, and in the output layer you have again 10 number of neurons. So H into 10. So therefore 160. So your hidden layer will have 8 neurons. So now I can complete the architecture. So it is like this. So now can you tell me that what kind of autoencoder is this one? 8 neuron, 10 neuron, and 10 neuron.
It's
Can you please? Sorry. Yeah, it's an undercomplete. So this is an undercomplete autoencoder. So that is why even though you can guess it that 80 plus 80, so the number of neurons over here could be 8. But this is the way that you should proceed. So in this way, we got to know that the bottleneck layer has been constructed with reduced number of neurons over there. So that is why this is the undercomplete autoencoder. Okay, so we can end the lecture here. And what I will do, I will upload this particular lecture in YouTube. I will upload the PPT as well, and the few problems are left. I will solve them and then I will give it to you as well with explanation as well. So only 4 or 5 problems are left. So I will solve it and I will give it to you. And probably this is the last class because this was the extra class that I had to take. So this is the last class from my side. And best of luck for the examination. I hope that you all ace the examination with good marks.
Thank you very much, sir. Today's lecture was really helpful.
Thank you,
It's going to help us a lot.
Thank you, sir.
Okay, so we can end the meeting here. So let me just stop recording.